Hello everyone. In this video, I'll explain you about GATE examination solved problems in design of steel structure course. The first one is P is the force acting on a centroid of section. Find out the ratio of two forces P1 and P2 acting on two sides of fillet welds as shown in the figure. So here is the diagram. This is the one angle section which is connected to gusset plate by using welding. Okay, we need to find out P1 and P2 ratio. So P is the force. So we need to calculate P1 and P2 ratio. So taking moment at P2, I'm taking moment here. So moment formula is force into perpendicular distance. Force is P1, perpendicular distance is H1 plus H2. So P1 into H1 plus H2 minus P into H2. Okay, force into perpendicular distance. I wrote P1 value. Like that, I'm taking moment at P1 and I'm writing P2 into H2 plus H1, same formula, force into perpendicular distance minus P into H1. That is force into perpendicular distance. Now the moment is here. So P2 equal to P into H1 by H1 plus H2. Why? Because where we are taking the moment, at that point the moment is 0. We know the equilibrium condition, sigma m equal to 0. So after finding P1, P2, we are going to find out the ratio. So I got the ratio H2 by H1. Like that we are going to solve this problem. And the next one is a double U-type butt weld is used to connect two plates 180 mm 18 mm each. A moment of 13 kN is acting. The amount of stress developed will be. So here we need to find out the stress developed which the double two plates which are connected to double U-shaped weld. Okay, for that we need to calculate the stress developed in the plates. So here section modulus of the butt weld, the formula for this is dB square by 6. So we know the d value. D is nothing but thickness of this plate and B is nothing but width of this plate. So I substitute those values in the equation. So I got 97.2 into 10 power 3 mm cube. Like that, stress we need to find out load by area. So load is already given in equation 13 kilonewtons. So 13,000 into 10 cube divided by this one. I got this value. Okay, and third one is a column has effective length L. When both ends are fixed, what will be the new effective length if one end become hinged? So in this problem, there are two columns. Two conditions are there. When both ends are fixed, is nothing but like this. The column is fixed at both ends. We need to know the condition. In table number 11, page number IS 800 2007, the code specifies effective length values. Okay, effective length of prismatic compression members. So the first case is both ends are hinged. This is the both ends are fixed. For fixed, effective length is 0.65 into L. Effective length value. So I wrote it is LE1, 0.65 into L. From this equation, I wrote L value, LE1 by 0.65. Like that, the second condition is when one end hinged. Okay, when one end hinged, LE2 equal to 0.80 into L. Here, one end is hinged is like this, another end is fixed. So I wrote L value. So by using these two values, I'm going to calculate LE2 because our condition is one end is hinged value we need to find out. So LE2 equal to 0.8 by 0.65 into LE1. So LE2 value is 1.23 into LE1 or 1.23 into L. Like that, we are going to solve this problem. Okay. In the next video, I'm going to upload design of batten columns and some other example problems for GATE examination in design of steel structure course. Thank you so much. Thanks for watching.